Yes.
Yep. Thanks, everybody. Yeah, same. Yeah. OTTO RYYNÄNEN from the Qt Professional Services. And talking about threaded items, I'm very positively surprised to see that so many people are interested in the topic, but this was supposed to be a common issue on people. But yeah, let's not have too much interactions. I'll immediately go in the fastest ever seen item view. It's 60 frames per second. And okay, frankly, hands up, how many times have you done this? How many times have you done that you put some spinner because your view takes too long to load? Yeah, point being. Now, this is actually some kind of a disease. You try to cover the fact that you have a slow model. Someone would say that, hey, let's put in a progress bar. It will tell the user how soon it's ready. Yeah. Yeah, no, it's not telling when it's ready. It's just telling that it's stuck. But this is the putting something over on a view is just telling that you want to show some content on the screen. My presentation today is key content on the screen. So let's actually get to show the actual data for the user. And today I'll go through the whole thing. Why do we need a threaded model and how it fits into the Qt model view architecture? Cases it's capable of solving. And for those who are not maybe actual developers, I'll show live examples. What this actually means in user perspective. And then I'll go into the very interesting part, the actual technical solution. And I'll start with the fact that why a threaded model, what is it needed for? And this here shows us lots of lists. That lady over there obviously has a list of something. A horizontal list of what seems to be ads. We have Windows settings. Obviously it's a list. If you expand this window, it will be a grid of icons, but that's a list model providing items. The same thing as in the coffee machine, built with Qt, by the way, is showing list of options, but they are put into a grid instead of actual list, a list model. And when you are swiping left or right, one item at a time, it's actually a list. You just see one item of the list per time. So lists are somewhat everywhere. And I come from the professional services. We help Qt customers with their projects. And I don't lie if I say that basically every customer at some point struggles with a list model not being as reactive as they would want it to be. I'll very shortly visit how the view model architecture actually works. So there is a view that says what we are going to draw, or basically how we are going to draw it. Put an icon at this point, put some color in here, text in here. It would define the font and so on, but it wouldn't actually know what the text is, what the color is. The model is providing that data. Now, for the examples I'm going to show you, and that's the core of the whole pattern in here, the view is normal view. It has no customization. Actually, every example passes different model to the same QML file to make sure that the performance for the UI is always the same. Model changes. But now here comes the thing. In basically every example you get to see, usually at least, there is a data source. This time it's a Steam-powered media player, Qt. And then there is a model, and the data just magically flows in. Even at the best, there is something, and it's there. I mean, usually this part is missing. How does the data go in the model? The examples pre-fill the model and the view is lightning fast. But in real life, what we have is the wall. Our friend over there found it. So a real software project, you have data source, it's something. It could be a log file. And if you have a large log file, it was created somewhere. You can't recreate it to be better to parse. It's as slow to parse as it is. You can't help it. Or maybe you have something, a web source, so it's behind a internet connection, and if you have bad internet, then it's slow to get the data. But in the other end, okay, I'll relieve our friend. In the other end, Vue needs to get data instantly from the model. Model needs to provide. These are synchronous calls. The row count function needs to return immediately. The data function needs to return immediately. If they don't, UI gets stuck. So these are in UI thread, have to be, and since they are in the thread that draws to UI, they need to return immediately. Now, my pattern here introduces a storage. This is just generally the place where the data is. And since row count needs to be able to get the count from storage, it means that the storage is in UI thread and has synchronous interface. Give me the count. Give me an item for the index in question. Fine. And then we have the data source, which is behind the so-called wall. So we can have asynchronous communication, and storage is handling that part. Now, shortly, what can we solve with this? Okay, let's go with the Pokemon style. Gotta catch them all. Let's solve all the problems. Well, let's say we have fast data, and it's small. It can fit in the memory. Then we are constrained by rendering. Then we are optimizing the view, and then we don't talk about that today because that's working already. So you have a very slow data. You can easily get it. Today we see a playlist of songs, 3,600 songs from the Steam-powered media player that returns 1 per second. So that's an hour to load the entire playlist. We don't have that time, I checked. So I'm going to show you how to make it so that we can view any song anywhere, even though we would need to take 1 hour to load the list. That's time constraint. We can hold all the data, but it takes time to get it. Then it could be the other way. We have very large data, so we are memory constrained. We could get it fast, but we can't hold all of the data. We need to forget it eventually. And then, of course, this could be both my current project and the source of the whole presentation. So, I promise we'll go to live examples. If one. Let's first of all take a very, very basic example. So let's say that our Steam-powered media player actually has only this interface. I hope this is visible to the last line. Should be. So yeah, we have get all. Returns you a list of media. I said that it would take 1 hour, so this function would return in 1 hour. Okay, this is nightmare case. We couldn't do anything on it, really. I mean, literally, it would take 1 hour. This is not what I actually plan to show here. I'm just saying that this is a real-life example. We had an interface in a mobile phone getting SIM messages, the SMS messages stored in the SIM card. It was one function that returns them all, and you have no idea how long it takes because it depends on SIM card. I think the record was something like 2 minutes. So obviously there are points when we can't avoid the data fetching, but let's take it a bit further. So if I could ask for items by count and some offset, which is like pretty generic usual case. You can say that I want 10 items from the very beginning, or I want 20 items starting from 15th item. This is something that we could handle with the fetch more functionality already in Qt item, the view model architecture. And actually I said one song takes a second, so let's optimize this a bit. Get me next item, because that's frankly what we are doing. So I'll do my best to show you then the example, which should be there. Yes, give me a second, we'll drop in here. So if we would be doing fetch more, it would look like this. So we are 1 second at a time getting a next song. The view is asking, is there more? Model says yes, there is. you can see in the top that we see how many songs we have, and it stopped at 12, which is because the view got all the info it needs. If I scroll down, it starts fetching more. But this is not having a thread, so I try to move the scroll bar, and it basically does something on the top, but as soon as I start loading, the UI thread blocks. And okay, this is useless at the best. But luckily, we could put this into a thread. We could have threaded fetch more. Looks same, except that I can click on anything I wish. We can see the songs directly. And then when I actually start to scroll this, yeah, it fetches more, but it doesn't interfere the UI, and I can immediately open songs if I wish to do so, even when it's loading. Fair enough. So that would be a case in fetch more. That would be the case with the existing Qt implementation. That would be boring. Can we get T content to the screen? Remember, I said we could get any song. This was 12, 13. My song is in the end of the playlist. We would need to go down for 1 hour to reach it. It's unusable. Well, I had this last time. I could ask for a number with an offset. What would it actually take to be able to ask the last song? I could just say that give me last song if I knew how many songs. So we need to count. Already seen before. And this is actually the interface in our example, which, by the way, is available in Qt examples now. So we have a count which is 3,600 items. Nice. And we do have, sorry about it, trying to find the mouse cursor. Yeah. And we do have, we can see 3,600 songs. It's still the same loading, but nothing prevents me from going to the last item. There it is. There's my favorite song. Now, the view in Qt model view architecture doesn't actually need any of the items in between. It only needs the visible items, so we skipped asking for any of them, and here we are. Problem solved. Now, one could at this point be asking that, okay, yeah, I also want to see songs in the middle. Yeah, we can do that. We can just scroll up. And after a while, yes, we start getting them. The view buffers few items below and above. That takes a couple of seconds because of 1 item per second. And I mentioned the case that if you are data constrained, the same logic actually applies. So let's do the same, but we have a limited number of items we can hold. So I start from the beginning again. Yeah, loading. Now, the storage is actually, in this example, it's having a limit. We can only hold a certain amount of items. So if I scroll down, one feature that actually happens, you notice this item is missing. It's not missing. We have limited amount of items, meaning that it stopped asking it and now is asking it. As long as the view needs the item, it gets loaded. We could go to the end of the list. That should be working just the same. My favorite song coming up, but yeah, it's taking us again some 12 seconds to load all items. Getting to the point, now if we go back to the beginning, that item still exists, and rest don't, and actually the very first item, yeah, now got into the list of items we no longer can hold, and is reloaded. Now all of this looks still a bit ugly, but now I need to explain. Customers that have had problems with their view don't have this. Steam-powered media players don't exist. Instead, the usual cases have been like a tree view with, I think ugliest case was 200,000 elements in it, coming from a web source. We tried it actually, that let's assume perfect web providing you the data. We had already downloaded it and just threw it into the model, and parsing the web response took over a minute. So we would have been showing a spinner for a minute to actually show everything, and this is not acceptable. But with doing fetching just for the visible area means that we actually were fetching the data from the web only for portion of the data. In current project, we are having a list view which has, I think the ugly case again was 50,000 elements in a list from encrypted database. And the decryption takes a moment. It takes 7 seconds to load the full list. And we went with the same approach because we don't want to wait 7 seconds to get the full list. Now comes the question, if we are not actually needing to wait 1 second, how about if we can get 100 items per second? Well, this is how it looks. So I can again scroll down or scroll to the end. And yeah, the user can see that something, but not that much. And this would take 36 seconds to load full list. And it's instantly usable. There is no actual delay that would make it impossible for the user. Cutting 36 seconds into nothing. For 50,000 items loaded in 7 seconds, it means that loading the visible area is so quick you don't see anything else than the actual data. That's how the pattern works in practice. This is how it looks for the end user. Then I promise to show the technical solution in detail. The nice demonstration ends here. Sorry for those who weren't here to learn about the technology. And then, moving on. So, as I was saying, we have this storage. I'll drop the view out because it's always the same view. You could try this in your project and you don't need to touch the view at all. Actually, the model is basically just a thin wrapper. For data calls, it asks the storage. For data updated, it just tells the view that something was updated. View will request the data. So it's again just asking the storage. The model is merely providing proper interface for the view. And now, at the point, there is some things that I need to point out. We already discussed that yes, the storage needs the count. This actually has to be possible to be received instantly. If we need to wait 3,600 seconds to get the count, then this thing doesn't work. After that, we have a synchronous call for the data source. It's get items. It returns in 1 second. This is the pain point. And then few things that will come up later. We need to also tell the view about items being added or removed. Now, question is, where do we throw the worker thread? We put it here. So storage holds the data. Worker thread gets a signal that storage needs an item. And then worker thread will tell once it has the item, meanwhile it will spend time on communicating with the data source. And I want to point this out. This is probably the most important thing of the whole thing. The takeaway here is this. On the yellow area is UI thread. You need to, data doesn't exist in a thread, so to say, but the handling of the data, adding new items or removing items always happens in UI thread. I will come to this later why. At this point, I ask you to take it given. Yes, this is how it goes. The worker thread can prepare the data, it can be very ready, just place it in your list or whatever you use, but worker thread can't modify the data. Outside that, yes, worker thread handles anything that is taking time and being hard to do. This part goes into the UI thread. And then we get to the question, how will it look like in code? Am I going to be writing huge amount of code for getting this small performance benefit? No, you don't. This, and please, if this doesn't show in the back row, now would be a good time to say so, would basically be how the data function needs to be in your model. You get, this system is using IDs for the storage for a reason that I will soon explain better, but so we have an ID. The list of IDs is obviously telling the list size. We know that if you have 3,600 IDs, there are 3,600 items. They come in order. We know that the first ID is the first item. ID list is only thing that the model is actually holding. And then when we get data call, it just asks storage that I need the item for this ID, and rest is what you would do in your model anyway. 2 lines in here, plus the storage, which anyway would need to be implemented according to your project. So I'm very shortly going for the storage. And now, this, don't mind that you probably won't be able to read from the backline. The same thing, UI thread is in yellow box. Anything in UI thread has to be fast. Anything outside the UI thread can take time, like a second we've seen. So view is asking model that give me the data. Model is asking storage that I need item. Storage throws a signal, returns immediately that no, I don't have the item. And view, the model is handling to the view that, okay, here's the loading item. It says loading, show that one. And then this actually loops. The view is asking for all the visible items the same. Every time storage is throwing a signal and saying that no, I don't have the data. That was the print. And then view doesn't ask for more data because it can't render them anyway. They are outside of the screen. We do some 12 requests and be done. Then, yeah, the outside of the UI thread, worker finally gets the first item. It took a second. And tells that, yes, I have a new item. Throws a signal to storage that will send the Qt model view architecture data change signal. Worker continues its work. And yeah, data change causes the view to ask for data again. So the first item gets update, and this time storage has the data. So it returns the actual data. We get to see the album art, the song title, and so on. And this just repeats for every item in visible area, after which the whole thing stops because the view doesn't ask for more. Once you scroll down, we do this for the items that you are having in visible area. If you scroll directly to the bottom, that means you start loading the last items. If you do it slow enough, you basically trigger fetch for every item, and that's where we have to limit from the worker side the amount of items that you actually fetch. Only fetch, like, let's say 20 last items. Actually, very simple once you get the idea that, oh yeah, that's how I should do it. Then I said that we could also see how this applies into a bit more complex cases. And next thing is dynamic models. I mean, this was static model. We have the playlist. It doesn't change. But how about if actually it does? How about if we are in a point that, oh, my item model has changes. There are more songs being added, or there are songs being deleted. That's a very normal case. Well, let's try move. This is from Qt documentation. This is how move looks like. Well, as I said, we are working with ID list, and this is the reason. The model can just directly move an item. It can say begin move rows, then moves up the ID in the ID list. It never needs to talk with the storage. That's unnecessary. After that, it tells that end move rows. And if the view happens to ask some new data, so let's assume that the item number 3 now actually became visible. View will ask data for ID 3. It's very equally same data as before. Storage can provide it or it can fetch it. That's move. Okay. Adding is the same thing. We add new IDs. Only thing the storage needs to tell the model is the actual index where to be adding the new IDs. Outside that, again, the view tells that I'm going to now update. I'm now going to add rows. So yeah, why not? there can't be any requests making this impossible because we know all the IDs before, and until this is done, the view doesn't know about the new rows or can't fetch the new IDs. We add them, bingo. Now you can fetch more data, storage will provide it. Then comes the remove. I said that the storage needs to have synchronous signaling towards the model, and this is the case. The model view architecture says, basically between the lines, that when you are removing, you say that, okay, begin remove rows. It signals the view that now items will be removed. Let's say that your song list actually at the top is showing you that this is the length of the entire playlist in hours, minutes, and seconds. The view would be at the point that, oh, row will be removed. It would read how long were these songs and reduce that from the total and then let the rows be removed so that the number is correct. So if we just remove IDs and then tell the view that this was done, yeah, there comes the problem. So what it would happen is, and sorry about not having the UI thread in here, basically it wouldn't really matter. Storage gets info that something is removed. So it would tell the model that, okay, I removed an item. The model would tell view that I'm about to remove something. View needs to know the data. It asks it from the model asks it from the storage, but hey, storage removed the data. Oops. So we would be putting in loading data, the time of the song would be 0 and the total would be messed up. So correct way is that the storage before removing item has to give synchronous signal to model that I'm about to remove item, which is then model is just rerouting it to view about to remove a row. Now view can ask the data, it can get the data, and then when we finally return all the functions, we remove the stuff and go behind. Let's assume that we remove an item that is not in the visible area. Well, first of all, usually view ignores this because it's not showing the item. It doesn't need to know anything. But if this would be the case, yeah, the view wouldn't have any data before because it was not loaded. So now at this point, view would ask for data. Storage doesn't have it, so it provides the loading data. It's same data that view had, and it doesn't matter. So for all the stuff, only thing you need to have is the about to remove, and yes, I now have removed it, signals. And then yes, you can also dynamically remove things. I actually ran into this problem that we tried to remove an item dynamically and failed to find the data. That's why I'm now saying that this is needed. But good stuff. Proxy models. For those who don't know, I'll briefly go through. Proxy model is for we have a data model, and proxy model behaves like a view. It's asking data from the model. Model doesn't know that it's providing data for proxy model. It's same thing that it's providing data. View, on the other hand, is using proxy model. It doesn't know that it's not accessing the actual model because the proxy model provides the same interface. And then proxy model in between can do stuff like sorting or filtering. Could we apply this? Let's see. So let's try the filtering. And again, I'll explain what's going on. You don't need to worry about not seeing this. Sticking with the idea, we should be doing fast stuff in the UI thread. So filtering starts by view asking how many rows. This is actually a valid question. If your filter cuts everything off, it's 0 rows. So now, in this case, the proxy model asks for the row count, like the real row count. Yeah, our model tells that 3,600 songs. Perfect. And then, for all 3,600 items, the proxy model is asking for the data because it needs to evaluate if this item is being shown. And we throw 3,600 triggers into the queue after which the proxy model will tell that, yeah, 0 rows, we don't have any. Then 3600 signals start flowing in, and every time the proxy model evaluates, should I actually show this item? And this, in majority of the cases, that no, I shouldn't. And it takes 1 hour, and we actually have filtered the whole. Okay, we don't do this. We do it the smart way. We do the smart filtering. Sorry for stopping to that one. Let's add 1 role. This is now into our model, the source model, the threaded model. 1 additional data role, which is, in this case, is loaded. So we ask from the storage that, do you hold this data? Well, storage knows if it has the data. It has to know when to send a signal and when not. So you can ask from storage that, do you have it? Storage doesn't fetch anything. It merely tells you, yes, I have the data, or no, I don't. And for the question, is the item loaded? Answer comes in if the storage has it. For any other data role, we just ask the data in a normal way that could trigger fetch in the storage. Now for the filtering model, it's asking, is this row shown? Does the filter accept the row? It checks first the is loaded row. If this is that, yes, it's loaded, then we check the filter. We have the data, we can check if this item should be shown or not. And otherwise we say, yes, it is shown. That's counterintuitive. We don't know anything about the item. Why are we showing it? And this is the trick. If you remember how the thing works, we don't show that one, we show the loading item. So we would be showing loading items, and when the data comes in, the filter will check if the item is actually shown. Some of the items stay, some gets removed, and new loading items come in. Now for the 3600 songs, it's just plain physics that it would take 1 hour to find a single song that we want to show and remove rest. But for the real cases, the customer cases we have had, okay, I said it was 7 seconds long list loading. So if you actually, and we did add there a search function. I need to find everywhere in the list where Jürgen is, so I'll type in the search where Jürgen. Now we show first loading items until we find anything with Jürgen. If they are in the beginning of the list, it's snap, ping, there. Because, we just needed to load few items and it took 7 seconds to load everything. And in the most ugly case, we have 1 item with Jürgen, it's the last one. So it takes 7 seconds for the list to shrink until we see that, oh, nothing. Or only 1. And yes, we did add the busy indicator for that one. Unfortunately, we did. But the thing is, in that case, the user can understand, I did a search, it might take a while. But in usual cases where the filter matches to lots of stuff, it's so fast that you don't actually get to even see any spin. And then shortly, in action, the in UI thread, we will be asking for the is loaded role. Bingo. We get back to the view with no reaction into the actual thread. And then once we are fetching, after we have received the data, receive signals, again, anything needed is checked. And the proxy model tells the view if data change or row was removed. We don't need to think about that in our model. We don't need to think about that in storage. We only needed that 1 role that is telling if storage has the data. And that's it. That's very small effort. Now comes the last thing. That's the sorting. If we want to actually sort something. Don't mind me walking around. Now, here comes the problem. How would it actually impact? I personally feel this one guideline for software development and even on life altogether, just because you could doesn't mean you should. This is the case with the sorting. So let's remember our original case, 3,600 songs. We can't know their order without having every single song. We could sort the first 12 items and they could actually be last 12 items. We don't know until we load the whole list. It takes 1 hour. So you couldn't use this for sorting. Then, yes, remember the case of 200 items in a tree view? There we needed it. And there the case was that we actually tried how it would work if we just start loading the items and fixing the sorting on the go. I try to explain it. So in UI thread, we get the count, we see that, okay, we have 100,000 items in our view. Then someone says that please sort this, that's how the sorting works. Someone actually triggers the sort, where the proxy model now needs to evaluate, is this item more than this other item? So it loops for every 100,000 item a data reading. And it's worse. It reads the first item, it reads the second item. They both are loading items, so it sees that, okay, these are same. Then it takes effectively the third item, compares it to the first item, again reading the first item, again getting the loading item, and saying, oh, these are same, I'll just leave it where it is. And rereading items to compare them finally hits the end, nothing has changed, but we have 100,000 triggers. And then the ugly part, you start actually getting the data, which means that now the proxy model can see that, oh, this item should be in the beginning, and starts adding stuff in the beginning, losing the stuff to the bottom, and this whole thing flickers up and down and eventually stops, and user has head spinning like we developers also had. It was unbearable. But there exists a workaround. In that case, you could ask the IDs from the network. We always had the full ID list, all 100,000 IDs. That was Snap. We took it when the application starts. So you could add IDs ordered. So tell the network that please give me the ID list, but sort them by name. We don't get any data. We get just the IDs, and we can just not do sorting. When user says that no, I wanted to sort by address, fine. Again, ask network that please give me the ID list again, but this time sorted by address, and again. So using proxy models, no, please no. But can be workaround if possible, if the stuff behind the wall, so to say, would provide it. I know you all probably have your head spinning, trying to think about, oh, what does it actually mean? How would it look like? And yes, the demo you saw, the Steam-powered media player, is in Qt 6.9.1 examples. You can find it in Qt Creator. You probably can easily identify that Steam-powered media player. And you can also see in the Qt Quick examples and tutorials page over there. That's the place where you will see it. Threaded list model example on layouts and views. Actual name is threaded song list example in the Qt creators, but yeah, start searching with threaded. You can find the threaded fetch more, you can find the threaded item view. It's over there. We want to serve the open source community, we want to serve the commercial community, so let's make it visible in Qt Asset for anybody to benefit. And then small add in here. I'm coming from the Qt Professional Services, as said. This is kind of a stuff we do to help our customers. This and anything else. Customers come with a problem. We have actually been improving boot time of an embedded device. We never actually needed to touch anything in the Qt. Their boot time problem had nothing to do with Qt, but we are full service company, we help them anyway. And yeah, you can come to meet us at the Ask Me Anything booth over there if you have something.